So good morning, everyone. This is your physics class. I am your sir, and we are here on lecture number 3 in units and dimension. Now, if you recollect what we did in the previous lecture, because it was 2 or 3 days back, if I remember, and what we had done was we had discussed what do you mean by unit, what is basic unit, what is fundamental unit, derived unit. We are also given one letter to each physical quantity, the fundamental physical quantity, 7 fundamental physical quantities. We had given them capital letters and they were known as dimensions. We had also seen dimensions of some quantities that we would require in our discussion in this particular year. So we are going to only concentrate on those dimensions and those physical quantities which we are going to require very immediately. As you can see, there is a long list, and I would send you that entire list of all those physical quantities that would be required in the coming 2 years. But right now, we'll only concentrate on those physical quantities which we require. Some of these we had discussed in the previous class. I hope we remember: distance, displacement, speed or velocity, acceleration, force, work, and energy. Do you all remember this? Can I have some raise hand that we remember this? All of these quantities. Remember, we'll have to remember all these quantities and we'll have to remember their dimensions as well, because believe it or not, a question definitely comes from this chapter, units and dimension, whether it is any exam, it is JEE Main or JEE Advanced or NEET. One question is there in this topic. So we'll go ahead and we'll just have a look at some of these quantities, and I would hope that you make a table out of it. I'll be sending you this table in your Telegram group. Don't worry. But still, you will have to note down the physical quantities that we are concerned with. I hope everyone can see my screen. The first quantity is velocity or speed. We have already seen the SI unit. SI unit is meter per second, and the dimension is M is not there. Therefore, M0, if you want to write, you can write M0. LT minus 1. Acceleration we had also discussed. SI unit meter per second square. Dimension is M0. Mass is not there. LT minus 2. We'd also discuss momentum. Yes or no? Do you remember momentum? Do you remember momentum? Yes or no? How many of you remember momentum? Not many people. Okay, momentum is written or described by the letter P, as you can see, and it is simply mass multiplied by velocity. So if you don't know this, you can just notice down momentum is mass multiplied by velocity. It is also a vector quantity written by the letter P. So you multiply mass with velocity. Velocity is meter per second. So momentum becomes kg meter per second, and the dimension becomes MLT minus 1. You'll have to remember all these dimensions. You'll have to remember all the SI units. There is no escaping this fact. Then there is the next quantity. You might not have heard about it. Impulse, written by the letter I or sometimes even J. Have you ever heard about this quantity, impulse? How many of you know about this quantity? Raise your hands. Impulse. For those who don't know, remember, impulse is change in momentum. Change in momentum is known as impulse. So I will write it as delta P. I will write this quantity as delta P. Now, whenever I use the term delta anywhere, remember this term delta, it might look like a triangle. It is not a triangle. It is a Greek alphabet, delta, the thing that I have highlighted in yellow, delta. Delta always means that it stands for change. So this symbol always stands for change in something. Right now, it stands for change in momentum. So delta P stands for change in momentum. Whenever we talk about change, bacha, change is always final value PF minus PI. F standing for final, I standing for initial. So PF minus PI, final momentum minus initial momentum, is known as change in momentum, and change in momentum is also known as impulse. We will be dealing with this term in your third chapter. Considering units and dimension is the first chapter, motion in 1D and 2D is the second chapter, force or Newton's laws of motion is your third chapter. That is impulse or change in momentum, and since it is change, that unit is same as momentum. So as you can see, this unit which is highlighted in green and this unit, they are all same. So whether it is momentum or whether it is change in momentum, they have the same unit. Do we understand this? Can I have some reason that we understand this? Everyone in the class, be there in the class, make your notes. I will be sending you this sheet. Don't worry. From today onwards, probably I will also send you the entire class notes. I will convert them into a PDF and send it into your Telegram group. So I'll convert this entire whiteboard or blackboard or whatever you call it. This is my notebook. Convert this into a PDF and I'll send it to you so that if you have missed something, you can note it down. Moving ahead, the next thing is force. We had already discussed force. Force is F, denoted by the letter F. It is equal to mass into acceleration. It's better if you write it this way so that you'll also get an introduction of what is force. Mass into acceleration. You multiply mass by acceleration. The SI unit is kg meter per second square. You can also call it Newton or capital N. And the dimension is MLT minus 2. Everyone knows this now. The next thing is pressure. P, pressure. Pressure is force upon area. This is also written by the letter P. Force upon area. Do we know pressure, force upon area? Yes or no? Force is pressure upon area. This is also known as Pascal. So you can also write it Newton per meter square. This is one way of writing it. You know Newton is kg meter per second square. So from there you can get the SI unit. You can also call it Pascal. You can call it Newton per meter square. And the dimension will be ML minus 1 T minus 2. Do you understand how I have derived this dimension ML minus 1 T minus 2? I have divided force with area. Force is ML T minus 1. I have divided by area. Area is L square. So ML T minus 1 divided by L square, and you get ML minus 1 T minus 1. Do we understand this? Can I have some reason that we understand this? Very good. Then we have energy. Now this formula for energy, the dimension for energy, whether it is any type of energy, whether it is kinetic energy, whether it is potential energy, whether it is heat energy, whether it is electric energy, whether it is magnetic energy, spring energy, any energy will have the same unit and same dimension. We have also discussed that whatever is the dimension of energy, same is the dimension of work. Yes or no? It was in the previous class. And this work done or energy can be found out by force multiplied by displacement. You can also call the SI unit as joule. So joule becomes Newton multiplied by meter. Newton. SI unit of force is Newton. Newton multiplied by meter becomes your joule, or your work done, or your kinetic energy, or your potential energy, or heat energy, or light energy, or whatever energy. Then you can easily get the dimension. This dimension will be force ka dimension MLT minus 1. No, MLT minus 2 multiplied by L. So it becomes ML square T minus 2. I hope everyone is following me. Yes or no? Raise hands will give you more confidence that we are there in the class, everyone. Okay. Then the next one is power. And I hope you have heard the term power. Power is, you can write is again written by the letter P, work done per unit time. So this is work per unit time, how much work I have done and how much time. You divide both of these, you will get power. So what you got to do, you have the dimension of work, divide it by time. It is also known as watt, or it is also known as joule, which is work, divided by seconds, which is time. Joules per second. Joules per second. What? SI unit of power. You might have heard. Yes or no? SI unit of power, joule. Yes, you have heard it. That's why joule per second. You have heard it. Then how do you get the dimension? It's pretty simple. You know the dimension of work, divide it by time, and here you end up, as you can see from here to here, the only difference is it is divided by time. So M L square T minus 3 becomes its dimension. That's the dimension. Power.
Hello.
You understand this better? Anyone has any doubts? I hope everyone is there in the class. You understand this? Yes. Any doubt? Please come up if you have any.
Hello, good morning, sir.
Yes, good morning, beta. Tell me what's the problem.
Sir, once can you explain this, how this dimension formulas are coming for each unit?
You don't know how to get the dimension formula of force, beta? Mass into acceleration?
Yes, sir. Sir, but for acceleration, how L power 1 T power minus 2 came, sir?
Acceleration, you don't know how did we get acceleration? That was in the previous class. Velocity divided by time. The dimension of velocity is LT minus 1. You don't remember it? Divide it by time, so it becomes LT minus 2. What is the problem there?
Okay, sir.
Okay. Then we come to the next one, which is density. Density, you know what is density? We all know what is density. Density is mass per unit volume denoted by the letter D, or sometimes I will denote it by the letter rho. It might look like a P. It is not a P. It is rho. Greek alphabet, rho. Rho is density. That will be mass divided by volume. Now what I'll do is, I will hide this dimension. And now I'll ask you to derive the dimension of density. So I've hidden it, crossed it. Can you get me the unit and dimension of density? Remember, to get the unit or dimension of any physical quantity, you must know how that quantity is derived. So I've told you, density is mass divided by volume, mass per unit volume. Now can you tell me what is the unit of density and the dimension of density? Yes. Mass per unit volume, it is very simple. This is how you get the dimension. Yes, tell me, what is the SI unit first of all?
Sir, kg meter cube, sir.
Kg meter cube or kg per meter cube?
Sir, kg per meter cube, sir.
Right? So this is mass divided by volume, m divided by v. So for mass, the SI unit is kg. For volume, is length into breadth into height. Meter into meter into meter. So it becomes meter raised to the power of 3. So kg per meter cube becomes the SI unit of volume, of density. This is how we have derived all the above dimension and all the other units. Yes or no? Do we understand this? Now you can get the dimension very correctly. Just put the dimension of M and put the dimension of V, divide them and tell me what is the dimension of density. Tell me, what is the dimension of density? What is the dimension of density?
Hello.
Yes, beta. What is the dimension of density? Did you get it? No one?
Hello.
Sir.
Yes, beta.
Hello.
Yes.
Sir, m power 1 into?
So mass is M. Yes.
power 1.
Okay, 1 is same.
Sir, L cube.
L cube. Are you correct? L cube or something else?
Minus, sir. Sorry, sir. L power minus cube into T power 0, sir.
We don't have to write e to the power 0. So it is simply becomes M L raised to the power minus 3. Do we understand this?
Yes, sir.
Everyone understands this? Yes or no? Can I have some reason that you understand this? Everyone? Well done. I'll give you one small task and I will tell you what something is, and then I will ask you to tell me its unit and dimension. So here is a small task for you, which is coming on your screen
Hello.
right now. Yes, Victor. I'm hearing hello. After that, it's nothing. Yes, Beta, tell me what's the problem? Okay. So here I am telling you one more physical quantity, torque. Have you heard about torque? Okay, someone has heard about torque. That is really great. Torque. Now you might not know what is torque, so I'll tell you what is torque. Torque is force multiplied by distance. Force multiplied by distance is torque. Now can you tell me what is the SI unit and what is the dimension of torque? I'll give you 1 minute to do this. I'll give you two questions here. One is torque and the other one is angular momentum
Sir,
divided by L.
sir, for torque. Hello, sir.
One is angular momentum divided, which is written as L, and angular momentum is momentum multiplied by, let us say, distance. So these are the two questions that I'm giving you. Torque is force multiplied by distance. Angular momentum is momentum multiplied by distance. I'll wait for your answers.
Hello, sir.
I want two answers. Let me finish, beta. I want two answers here. One is the SI unit of torque. Other one is SI unit of angular momentum. And then I want the dimensions of both the quantities. So I want SI unit and dimensions of both torque and angular momentum. Now, if you have any problem, please
Sir,
ask.
Newton. Sir, Newton per meter, sir, for torque.
Okay, it's not correct. It's wrong.
Newton into meter.
Yes, Newton into meter would be torque. Force is Newton multiplied by meter. But what about the dimension? What about the dimension? Remember the dimension of force. You'll have to remember all these things. I have highlighted it. Right now, I highlighted it here.
Sir, same as joule, sir.
Yes, it will be same as joule, but you have to remember the dimension of joule. You cannot say, you cannot write in the exam that it's the same as joule. You'll have to remember the dimension of joule or energy or work. What is the dimension of joule or energy or work? Tell me that. I've again highlighted it. You'll have to remember all these things, beta. You'll have to remember all these things. So what is the dimension of torque? What is
ml square t power minus 2.
Very good. ml square t minus 2. That is the correct answer. Everyone got this? Can I have some reason that everyone got this? Anyone has any problem? Please come up. This is very simple. You just have to know how the physical quantity is made. That is the definition of dimension analysis. What do you mean by dimension? Dimension only tells us what are the powers of fundamental quantities which make this new physical quantity. And that is what we are doing here. We are just telling each other, we're just getting to know how a physical quantity is derived, what are the things in it, how much mass, how much length, how much time, how much current, how much mole. Mole and current are not going to come now, so we'll just leave it. How much mass, how much length, and how much time. That is our entire discussion right now. Now comes the angular momentum. I told you, you might not have heard about angular momentum. I've told you, it is momentum multiplied by distance. Now I wait. Now I wait for the SI unit. And the dimension of angular momentum? Can anyone tell me what is the SI unit and the dimension of angular momentum?
Joule per second, sir.
Joule per second. No, that is wrong. I don't know.
Sir, joule into second, sir.
Yes, you always are making a mistake in multiplication and division. Whenever it is multiplied, you are saying it is divided. Whenever it is divided, you are saying it is multiplied. So please have a look. Angular momentum, rate of change of momentum. You might have heard rate of change of momentum is force. So momentum is force multiplied by time. So force multiplied by time is momentum, and then you multiply it by distance. Now, if you can't understand it in terms of Newton and meter, Newton and Joule, don't worry. Remember the formula. Remember the SI unit of momentum. What is the SI unit of momentum? It is mass into velocity. Mass is kg. Kg is mass. Velocity is meter per second. So this entire thing becomes kg meter per second becomes my momentum. Do we understand this? Yes or no? Kg is mass multiplied by velocity, meter per second, that becomes momentum. Now I simply have to multiply it by distance. So distance ka SI unit is meter. So I multiply it by meter, and that gives me the SI units of angular momentum. So the SI unit of angular momentum becomes kg meter square per second square. Do we understand this? Yes or no? Oh, not second square, meter square per second. Do we understand this? Yes or no? Now, it's very simple to tell me what is the dimension. Oops, what I've done here. What is the dimension of this thing? The dimension of this thing is kg ka dimension is mass, meter ka dimension is L, so ml square. Second ka dimension is t. It is divided by t. I cannot write divided by t, so I will write it as t minus 1. So ml square t minus 1 becomes the dimension of angular momentum. Are we following this discussion? Yes or no? Anyone has any doubt? How we are finding out the units? How we are finding out the dimension? I'll give you 1 minute to go through this. If you have any problem, beta, please ask me. Doubts must be cleared here and now itself. I'll give you a minute. You only have to do those dimensions that I am telling you right now. You can see more dimensions here, angular displacement, angular velocity. We don't need it right now. We don't need it right now. That is why we are not going to discuss it. I'm only concerned with the dimensions that we are concerned with. So I'll give you a minute. Think about it. If you have any doubt, ask me, because then I'll give you 1 or 2 small questions to solve. I'll give you a minute to think about it. Okay, I hope everyone has noted down till now. There are also two things that you might remember because we might require it in discussion that is going to come. One is time period. Everyone knows what is a time period, beta? Time period? Time period of a clock, time period of a pendulum. Have you heard this term, time period? The time taken to complete one circle, one rotation, one oscillation. Do we know this? Yes or no? Yes. Time period is time. Therefore, its SI unit is seconds. And the dimension is simply M is not there, L is not there, only T. Time is there, T raised to the power 1 or simply T. That is time period. Please remember this because we might be requiring this. And if you know time period, you would also know frequency. Do we know frequency? Yes or no? It is written as N here, but normally it is denoted by F, small f. Frequency is the inverse of time period. Time taken to make one revolution is time period. Number of revolutions in 1 second is frequency f. It is inverse of time. Please remember this because we will be needing this. It is the inverse of time. So it is 1 by second, which is also known as hertz. It is 1 by second, also known as hertz. And therefore, beta, if you can see, the SI unit is M is not there, L is not there, T is there, but T is raised to the power of -1 because it is divided by second. Do we all understand this? Yes or no? Okay, then I'll give you a minute to note this down. Then I'll move on to some important points that you will have to remember about these dimensions. You cannot forget this point at any point in life, at any point in time. And we will start with those important points here. And remember, I've told you how to make notes. Whenever you are making notes, your notes must be foolproof. Whatever important points are there must be duly marked. Whatever important questions are there must be marked. I was just doing a webinar yesterday and the students who were going to appear for JEE Advanced, they were there. On 200, 300 students were there. And they were asking me about all this, how to prepare in the last 5 days. I just told them, whatever notes you have made, whatever questions you have marked, just go through those questions and you would be good enough to appear in any exam. And I'm giving you this advice right now, not after 2 years when you're going to give for your go for your JEE Advanced or Mains or NEET. Make your notes properly. Write all those important things very clearly. Mark them. Write in your language, Hindi, English, Tamil, Telugu, Malayalam, whatever language you are comfortable with. Write it in that language. This question tells me this. Please solve this question when you have this doubt. Write all those notes, mark them so that whenever you want to revise, if you have to revise, you just read that note. Okay, this is what this question will remind me of that thing. So then you can just do that question and your revision is over. Do we understand this? Can I move forward now? Yes? Everyone has noted this down. I hope all of you are following me and I hope all of you are making your notes. Please take my advice seriously. Now we come to some important
Hello,
points.
sir. Hello.
Yes, beta.
Sir, no need of writing remaining quantities, sir.
No need. Only those quantities that I told you, beta. I'll be
Okay.
sending you this entire PDF. I'll be putting it in your group. Don't worry. I will also putting this entire running notes in your group. Don't worry about that. Just write only those quantities which I had marked and which we have discussed. We don't need anything apart from that. The entire list is very long. It's around 4-page list that I have there, and it has around 100 quantities which you are going to study in the coming 2 years. I'll send you that list in your Telegram group. Don't worry, you don't have to know all those quantities. It's not possible for you to understand all those quantities. Don't worry about that. Let me move ahead and write some important point. The first point is also known as the principle of homogeneity. The first point is known as the principle of homogeneity. Now it might look very complicated from its heading, but it is quite simple and you already know it. What do you mean by the principle of homogeneity? I have already told you that in the previous class. I may not have uttered this complicated term, but I have already told you in the previous class. What is this principle of homogeneity? What is this principle of homogeneity? That is the first important point. Anyone can guess what is that principle of homogeneity? You don't remember. Again, I have not told you that. So it is very simple. Whenever you have an equation in physics, no, we are not talking about equation in maths. It's also valid for equation in maths. It's also valid for equation in chemistry. But right now we are concerned only with physics. Whenever we are writing any equation in physics, we'll have some quantity, some physical quantity on the left hand side and some physical quantity on the right hand side. Yes or no? Yes or no? We'll have some physical quantity on the left hand side. We have some physical quantity on the right hand side. And if this equation is correct, the dimension on left hand side should be equal to the dimension on right hand side. So this is known as the principle of homogeneity. The dimension on left hand side should be equal to the dimension on right hand side. Remember, I told you, whenever you want to compare any physical quantity, you can only compare it with the same quantity in the same unit. Do you remember this? Yes or no? So if two quantities are equal, they have to be same. So if I have time on left hand side, there must be time on the right hand side. Otherwise, the equation is wrong. I cannot write an equation where I write force is equal to acceleration plus distance. Can I write an equation like this? Force is acceleration plus distance. No, I cannot write an equation like this. Whatever is there on the left hand side, same thing must be there on the right hand side. And therefore, the dimension of LHS and the dimension on the RHS must be same. Do we understand this? Yes or no? Great. Now, that is the first point. Now, remember, only physical quantity, only same physical quantities, only same physical quantities which obviously have same dimension, because if the physical quantity is same, the dimension have to be same. Only same physical quantity having same dimensions can be added or subtracted. Only same physical quantity, which obviously has the same dimension, they can only be added or subtracted. I can only add meter with meter. I can add seconds with seconds. I can add mass with mass, kg with kg. Can I add mass with time? 1 kg plus 5 seconds. Can I do that thing? Yes or no? We can't do it, right? So two physical quantities which are same, they only can be added or they only can be subtracted. Yes or no? No, yes. Do we understand this? Okay. Now, remember, the problem with physics is if you understand one statement, you'll have to also understand how you are going to use that statement in a question. How you are going to use that statement in a question, you'll have to apply that statement in a question. Now, how do I apply this statement in a question? That is the problem with physics. If you understand it from the first day, that this is the statement and this is where I will be able to apply it. This is the type of question where I'll be able to apply this. If you can do these things correctly, you would do extremely well. Now, how and where I am going to apply statement number 1 and statement number 2, let us have a look. Let me take an example. Let me take an example. F is equal to AT. I have written an equation which obviously is correct. I'm telling you this is a correct equation. Now, I'm telling you also that F here is force. My F here is force. Now, what is the dimension of force? Tell me what is the dimension of force? You don't have to look back. If you're looking back, that means you don't know.
Hello, sir.
Yes, what is the
Sir,
dimension?
hello.
Yes,
Sir, M into L T power -1.
T to the power -2. You'll have to remember all these dimension. If you don't remember this dimension, then whatever we are doing in the class is all going waste. So MLT -2 is the dimension of force. Will you be able to remember it now? Mass into acceleration. Acceleration is LT -2. Can I have raised hands from everyone that we have understood this? Okay, so force has a dimension of MLT -2. You'll have to remember this. Now, that's the dimension, that's the quantity on the left-hand side. Now, you also see a quantity on the right-hand side, which is A multiplied by T. A multiplied by T. Now, what will be this entire quantity A multiplied by T? What quantity would be this, which is on there, which is on the green side, on the right-hand side? What will be this entire quantity be?
Sir, M0. Hello, sir.
What will be this entire quantity on the left-hand side? On the right-hand side? On the left-hand
LT,
side,
sir.
I have
Hello.
force. On the left-hand side, I have force. What will be the quantity on the right-hand side? This quantity should also be force. Do we understand this? Yes or no? Because force can only be equated with force. Am I clear with everyone? Do we understand this? Yes or no? Anyone has any doubt? This is what I am applying the first principle of homogeneity. Whatever is on the left hand side, same thing is on the right hand side. Do we understand this? So A into T, whatever it's A into T is, it has to be force. And what will be the dimension of this quantity, A into T? What will be the dimension of this quantity, A into T? No one knows it?
Sir, M0 into.
It
Hello,
will
sir.
be equal to the dimension of force,
T.
which is MLT -2. Do we understand this?
Yes, sir.
Is it so difficult to understand that no one is raising their hands? Is it so difficult? Class which has less students, class number 2. Do you understand this beta? Everyone? Okay. So this is how I apply. This is how I apply the first equation, the first principle, the first important point, the principle of homogeneity. This is how I apply. So remember, in physics, you will have to apply concepts in questions. If you don't understand the concept, you will not be able to apply it in the question. So it's important for you to do two things. First, understand the concept, and second, understand the question in which you are going to apply that concept. That was the application of principle of homogeneity. Now let me take one more step and move further ahead. Let me now write another equation. This was example number 1. Let me move on to example number 2. Now this example is like this. P is equal to A plus BT plus
Sir, I have a doubt, sir. Hello.
P D by T square. Beta, please, when I'm talking, let me finish what I am saying, and then you can ask whatever doubts you have, okay? So now I am written an equation. P is equal to A plus BT plus C D by T square. We'll be doing this question, but yes, what is the doubt?
Sir, actually, force means mass into acceleration, sir, according to Newton laws of motion.
Yes.
Sir, but you written acceleration into time.
Did I say that A is acceleration and T is time? Did I say that?
Sir, you asked now, sir, for
Did I
acceleration.
say
but-
that A is acceleration and T is time?
No, sir.
That's it. I only told you F is force. So you cannot assume anything on your own unless and until the question tells you that this is this. Okay. A is not acceleration always. A can be anything. A can be length. A can be height. A can be anything. A is A. A is not acceleration. Okay. Shall we move ahead? Now again, I have an equation. Now, what is there in that equation? You don't know. But on the right hand side, you can see three different terms. Do you see three different terms? Yes or no? The first one is yellow one. The second one is the green one. Oops, I did not get green. Why did I not get green? Okay. First one is yellow. The second one is also yellow. Let me see if I can change. Now it's become green. Now it's become pink. Okay. The first one is yellow, A. The second one is mixed color, B into T. The third one is, I think, green, C into D by T square. Now you don't know what all these terms, you are just guessing. But you can say one thing very, very correctly and carefully and rightly. What can you say about dimensions of these three terms? Are these dimensions going to be same or are these dimensions going to be different? Three different terms are there. Three different physical quantities are there. A, Bt and CD by T square. What do you think about the dimension of these physical quantities? Will they be same or will they be different? Or you don't know. You can't.
Sir, same, sir. Same, sir.
They would be same. Yes or no?
Yes, sir.
Why they would be same? Because only those physical quantities can be added or subtracted which are same. So this is an application of point number 2. Do we understand this? That is how you apply things that you study in physics in practical questions. If you understand these things, you will be able to solve any question that comes in a JEE. Okay, so A, dt and C d by t square will have the same dimension. All of us agree with this? Can I have some raised hands? Okay, now I am telling you, beta, that this quantity on the left hand side, P, this is actually pressure. This is pressure. Now, first of all, tell me what is the dimension of pressure. First of all, tell me what is the dimension of pressure. I am just asking you all of these things so that these
Sir,
dimensions become a part of your life. Yes.
Sir, m into L power minus 1 into T power minus 2.
Yeah, so this is how you should remember it. Well done. You had made mistakes in the beginning, but now you are coming up. That is great. Now, I've only told you on the left hand side you have pressure. Now I'm asking you what will be this physical quantity?
Sir, mass, sir.
What will be A equal to?
Mass, sir.
What will be A equal to? Remember all these physical quantities, whether it is A or whether it is B into T or whether it is C into D by T square, they are all same. What will be A equal to? Which physical quantity would be A? Which physical quantity would be A? Anyone?
Mass, sir. Mass.
Well done, mass. So on the left hand side we have pressure and the right hand side we have mass. Pressure is equal to mass. Is that correct statement? Pressure is equal to mass. Will that make any sense? Will that make any sense? Will it make any sense? Tell me, beta. No, it will not make any sense. Because pressure cannot be equated to mass. So A should be pressure. Are you getting my point? This entire quantity A must be pressure. Do we get this? Yes or no?
Hello?
Yeah, are you getting this data?
Hello?
Yes.
Hello, sir?
Yes.
Hello, sir?
How many times you will say hello? Yes.
Because you're not saying no, sir, whether the voice is coming or no. That's why I'm asking, sir. Voice is coming, sir?
Yes.
Thank you, sir.
So you wanted to ask anything, or you just wanted to check whether the voice is coming or not? Okay. Do we understand A is pressure? Yes or no? Do we understand A is pressure? Yes or no? What about this quantity B into T? This entire quantity B into T. What will be this entire quantity B into T? Tell me.
Pressure, sir.
Pressure. Well done. What will be this entire quantity CD by T square equal
Sir,
to?
pressure, sir.
Okay. Pressure here, pressure here, pressure here, and pressure also on the left hand side. Now you will say, sir, this is P. Let us say pressure. This is equal to A is also pressure plus B is also pressure. Second quantity is also pressure plus third quantity is also pressure. So on the right hand side we have three pressure, and on the left hand side we have one pressure. What is the why it is wrong, sir, or why it is right, sir? Remember, we are not adding these quantities. We are only looking at their dimension. Pressure on the left hand side, so pressure must be there on right hand side. Now there can be one pressure, there can be two pressure, there can be three pressure, there can be infinite number of pressure. We are only adding those pressures. So left hand side remains pressure, right hand side does not become infinite into pressure, still remains pressure. We're only talking about the dimension. We're only talking about the physical quantity. Do we get my point? Yes or no? That is what I wanted to make you understand, that remember what we learned and then remember how we are going to apply this. So we have learned two things. First is the principle of homogeneity. Second is only same quantity can be added or subtracted. And this is how we have applied this. Have you understood this? Anyone has any problems? Please ask me now. If you have none, then we will move ahead and we will move on to the third point. We have talked about addition or subtraction of physical quantity. Now, what is the next point that we must address? What about multiplication, sir? What about division, sir? Can you divide different quantities? Can you multiply different quantities? Now, I ask you this question. Can I multiply and can I divide different quantities? Or I'll have to multiply or divide same quantity? I can only multiply pressure by pressure. I can only divide pressure by pressure. I cannot multiply pressure by something else. I cannot divide pressure by something else. What is your thought? Can I multiply or divide different quantities? Yes or no? Say, there is no right answer, there is no wrong answer. Can I multiply or divide physical quantities? Yes. Have I done this? Have I done this?
Yes, sir.
Where I have done this? Let us go back. Let us go back and see where I have done this. Now, if I take you back to the very first quantity that we discussed, velocity, I had multiplied. No, I had divided distance by time. Yes or no? Distance by time gives me speed. That's how I got velocity. In the second term also, acceleration, I divided velocity by time. I got acceleration. In the third quantity, I multiplied mass with velocity. In the fifth quantity, I multiplied mass by acceleration. In the sixth quantity, I divided force by area. That tells me that even if physical quantities are different, you can multiply or divide them. Do we understand this? Physical quantities which are different can easily be multiplied or divided, and that is the third point that we are going to write. Remember, it's not important for you to write it in English. You can write it in any language that you are comfortable with. The only point is you should be able to understand it. So the third point is different physical quantities. Oops. Different physical quantities, I will write it short, PQ. Different physical quantities can be multiplied or divided. I hope I am making sense and I am proving everything that I am saying. I'm proving it with examples that physical quantities which are same can only be added or subtracted. Physical quantities which are different can be multiplied or divided. Okay. Now there is one special case that you must remember. If you divide, and let me ask you this question, if you divide two same quantities, what will you get? If you
Sir, we
divide,
will get one, sir. One.
if you divide two same quantities, what will you get? You will get one. No. 5 meter divided by 2 meter, is it one? No, it is not one. If you divide two same physical quantities, what will you get? Think. When two same physical quantities, not multiplied, remember I'm saying divided, are divided, what do we get? 1 minute left since I write it. When two same physical quantities are divided, we get what? We get
Constant, sir.
we get a ratio. We get a ratio or number. We will get simply a ratio or number with no unit or dimension. We will simply get a number, and this number will not have any unit or any dimension. 5 meter by 2 meter is 3. It is not 3 meter. It is not 3 seconds. It is not 3 kg. Yes or no? Do you understand this? To divide two same physical quantities, we always get a number. I hope everyone has written this. So, remember this. Some quantities, the last point, some quantities are always numbers. There are some physical quantities which are always numbers. For example, they are ratios. If I give you an example, have you heard about relative density? Yes or no? Have you heard about relative density? Density of a substance divided by density of water?
At
That
4
is
degrees
number.
centigrade.
Refractive index. Have you heard about refractive index? Yes or no? Refractive index is also just a number because it is ratio of two physical quantities which are same. So these quantities are purely numbers. They don't have any unit. They don't have any dimension. Yes or no? Number 6, angle. Is the only physical quantity that has no dimension, but it has a unit. Angle. Angle is also ratio of two lengths, but it is special. Angle is special. Remember, angle is a special quantity. Why it is special? Well, it is special because even though it is a ratio, it should not have any unit. Obviously, it does not have any dimension, but it has a unit. And we know the SI unit of angle. What is the SI unit of angle?
Radian, sir.
Radian. So angle is the only physical quantity which does not have any dimension, but it has a unit. Do we understand this? Great. So I will wind off my class here today. I hope all of you have noted down what we have discussed in the class. I will send you all these notes together with that PDF which has all these quantities on your Telegram group. As soon as I'm added there, I've asked the office people to add me there. So I'll be sending you that. Don't worry. Make your notes. It's not important to make your notes in English. You can make it in any language that you are comfortable with. Just have to understand it correctly. Do we get this? So what we have covered in today's class, we have covered some important facts about units and dimensions. We are writing some important points that you will have to remember about dimension. 1 or 2 points are still left, which we'll require to solve questions. Since time was getting over, I did not want to speed up anything. I could have written the point, but probably you would not have understood this. That is why I've left a point. From that point, we will start the next class. And I hope that in the next class, you will be able to remember all these points that we have discussed today. Will you do that? Can you remember all those points that you discussed today in the next class? Keep your notes. I'll be sending you all these notes that I have made and the PDF in your Telegram group. That's it from my end. If you have any doubts, beta, feel free to ask me. But when I'm talking, please don't disturb me at that time because my rhythm goes and I'm a simple person. If my rhythm goes, it becomes difficult for me to come back to that rhythm. Okay, so once I'm finished within a statement, then you can ask your doubts. Let us meet in the next class. Take care. Have a good day, beta. Bye-bye.